Now we go for second problem. In this second problem, calculate the brake power output of a single cylinder 4-stroke petrol engine which is running at a speed of 400 rpm. The load on the brake drum is 24 kg and the spring balance reads 4 kg. The diameter of the brake drum is 600 mm and the rope diameter is 30 mm. So this is the problem. Now solution for this problem is, so given cylinder, single cylinder small n is equal to 1. Now 4-stroke engine is given, 4-stroke engine. Then k factor will be for this, k is equal to 1 by 2. Then n is given, rpm is given 400 rpm. Next, load on the brake drum, that is W. Load on the brake drum, W is given 24 kg. So then, 24 into, because we want in Newton, so 24 into 9.81. So this is 235.44 Newton. Next, spring balance, S is given. Spring balance, S is equal to 4 kg is given. Again, make it in Newton. 4 into 9.81 Newton. So 39.24 Newton. Next, diameter of the brake drum. So capital D, drum. Diameter of the brake drum is given 600 mm. So 600 mm, make it in meter, 0.6 meter. Next, rope diameter is given. Rope diameter. So rope diameter is D small rope, that is equal to 30 mm. So this is equal to 0.03 meter. Now find out the brake power. So the brake power formula is 2 pi nt by 60 into 1000. Now we have to find out the torque. So torque formula is again W minus S into R. So here R is equal to what? Diameter of the drum plus diameter of the rope. Diameter of the rope divided by 2. So 0.6 plus 0.03 by 2. The answer is 0.315 meter. So therefore torque is equal to W is given, so 235.44 minus S spring. Spring value is 4 kg, that is 39.24 Newton, multiplied by the R value. R value is 0.0315. Only 0.315. So torque is equal to 61.8 Newton meter. So substitute this torque in the brake power. So therefore brake power is equal to 2 pi into N. So N value is how much? 400 rpm multiplied by torque value 61.8 divided by 60 into 1000. So you will get the value of 2.58 kilowatts. So this is the brake power. Okay students, now the problem number 3. A single cylinder 4-stroke engine runs at 1000 rpm and has a bore of 115 mm and a stroke of 140 mm. The brake load is 60 Newton and 600 mm radius. So brake load is 60 Newton and at 600 mm, that is the radius, and the mechanical efficiency is 80%. Calculate the brake power and mean effective pressure. This is the problem. I will go for the solution. So first, what is the engine type here? So engine type is 4-stroke engine. 4-stroke engine means, so K value is 1 by 2. Next, number of cylinders, single cylinder, N is equal to 1. Next, speed, capital N, that is speed is how much? 1000 rpm. 1000 rpm. Next, bore is given. So bore means small d, you can use small d. So 115 mm. So 115 mm. So here the millimeter is there. So make it in the meter. So 0.115 meters. Next, find out the area. Area is equal to pi by 4 d square. So when you substitute this pi by 4 into 0.115 whole square. So you are going to get area 0.010 meter square. So this is the area of the cylinder. Next, stroke length is given, L is given. So L is equal to 140 millimeter, that is equal to 0.14 meter. So brake load. So brake load is given. So W is equal to 60 Newton. So now radius of the brake drum. So radius of the brake drum R is 600 mm. So what is the in meters? 0.6 meters. So 0.6 meters. Next, mechanical efficiency is given. Eta mechanical efficiency that is equal to 80%. So that means 0.8. Now we have to find out the brake power. So we know that brake power formula BP is equal to 2 pi nt into 2 pi nt by 60 into 1000 kilowatts. So substitute 2 pi into n. So n 2 pi n. So n value is 1000 rpm into torque value. Torque is T. So T you have to find out. T is W minus S into R. So separately you can find out. So T is equal to W minus S into R. So substitute the value of W is 60. So spring value is not given, it is 0 multiplied by R. So R value is 0.6. So torque is equal to 36 Newton meter. So 2 pi n into 36 divided by 60,000. 60 into 1000. So 2 pi n is 1000. T is 36 Newton meter divided by 60 into 1000. So for answer, so brake power BP is equal to 3.77 kilowatt. Next we have to find out the mean effective pressure. So MEP, what is the MEP? Mean effective pressure, PM. So where you will get the mean effective pressure? Mean effective pressure, it is there in the indicated power formula. So IP is equal to N, small n, into PM, LANK, 10 by 6. 10 by 6 is the formula. So now in this you don't know the mean effective pressure, PM you don't know, but you know mechanical efficiency. So mechanical efficiency is eta mechanical is equal to brake power by indicated power. Brake power by indicated power. So here mechanical efficiency is given 0.8 is equal to brake power 3.7 divided by indicated power. So therefore indicated power is equal to 4.71 kilowatt. 4.71 kilowatt. So substitute here 4.71 kilowatt is equal to cylinder number of cylinder is 1. PM you don't know, you have to find out the PM. And a length. So length or stroke length is 0.14 meter. 0.14 meter. And in the area, so area is how much? So area found out 0.010, and then n, so n is 1000, k is 1 by 2, k is 1 by 2 into 10 by 6. So 4.71 is equal to 1 is number of single cylinders, one cylinder, only single cylinder. PM you don't have to find out. So next 0.14 is the length, stroke length. Area is 0.101. Next into n, RPM 1000. Next K 1 by 2, 4-stroke engine, and 10 by 6 is the formula. So compute this, simplify this, you are going to get the mean effective pressure. So PM mean effective pressure as 4 bar. This is the answer. 4 bar is the answer.